Hello everyone. This video we are going to talk about section 10.2, the quadratic formula. Quadratic formula provides us the fourth method to solve a quadratic equation. Number 4 method. Yes, we have 3 methods covered before already in previous video. First method, solving by factoring. When do we apply that method? When you are actually able to factor that quadratic trinomial. Okay, the two solutions are two rational numbers. Second method, solving by applying square root property. Third method, solving by completing squares. And this is number 4 method, quadratic formula. I'm going to show you the content of the quadratic formula. And related with quadratic formula, we have a very important theorem. Okay, I'm not gonna copy them, like write them out. I'm gonna just show you. You can find the content in the notes. The note is posted in Moodle. All right. So here we have a quadratic equation: ax squared plus bx plus c equals 0. A, B, C are real numbers. Leading coefficient A is non-zero. We're going to label this quadratic equation as a star. Okay? And we define the value of b squared minus 4ac. This expression contains all the 3 coefficients, A, B, C, in the equation. We know A, B, C are numbers, so the expression b squared minus 4ac is going to be a number as well. Which number depends on the coefficients of the equation. So this number, b squared minus 4ac, is defined as the discriminant of the equation. Very important concept. Take time to remember this concept. b squared minus 4ac is called the discriminant of the equation. If the discriminant is positive, then the equation has 2 distinct real solutions. If the discriminant equals 0, then the equation has 2 identical real solutions. Okay, so here actually 2 identical. Remember in the previous video, I wrote a paragraph here. For any quadratic equation in complex number set, it has exactly 2 solutions. The two solutions do not have to be real numbers. The 2 solutions do not have to be distinct. There is a case the 2 solutions are identical. Okay, it seems like one solution, but they are actually 2 identical solutions. So if the discriminant is 0, then the equation has 2 identical real solutions. One number, of course. Number 3, if the discriminant is negative, then the equation has 2 non-real complex number solutions. And the 2 non-real complex number solutions are conjugate. All right? I'm going to give you the time to read the content and understand and remember it. Remember is very important in mathematics, remember. And how are we going to solve for the 2 solutions? Quadratic formula, okay? We have a song actually. Let me sing for you. X equals negative b plus minus big square root b squared minus 4ac all over 2a. Of course, you can find other videos help you to remember the quadratic formula. You can look it up. Whichever way could help you to remember the formula would be good. And you don't have to worry about remembering it. It's good if you remember it. But I will have this formula included in the formula sheet. The important thing is to understand the structure of the quadratic formula. Denominator is 1 term only, 2 times a, twice of leading coefficient. Numerator, two terms. First term, the opposite of b. b is the coefficient of the middle term. Plus minus in the middle. And the second term is the square root. The radicand of the square root is the discriminant. You see that? Okay, so we're gonna I'm gonna find a new page. Actually, I can maybe continue from here. Yeah, again, I don't want to spend too much time to go over the content of the formula and the theorem, because the video is not very reliable. Remember the previous video, I actually made it a 1 hour long, but turns out it only like 32 minutes altogether, and some parts are compressed for some reason. So I don't want to waste time on that. So let's see examples. Use quadratic formula to solve a quadratic equation. Number 1, 5x squared equals 3x. By the way, we have learned 3 different methods to solve a quadratic equation. So if you could identify, maybe I could use the factoring method to solve this equation easily. You are good. That's good. That's true. Yeah, but we are practicing. The purpose of this example is to practice applying quadratic formula. So bear with me. Let's get familiar with the quadratic formula. First thing to do is to rewrite the equation in the standard form. 5x squared minus 3x plus 0 equals 0. Yes, the constant term is missing. Okay, constant term is missing, so I put a 0 there to hold a place. And then you're going to tell me what is A, what is B, what is C. A is the leading coefficient. B is the coefficient of the middle term. Middle term, you know, we have 3 terms. Leading term is the first. Constant is the last. The term with x is in the middle. So the coefficient is -3. Constant term is 0. Be careful with the sign. And I'm gonna find the discriminant first. This is how do we find it, okay? I use the parentheses to hold a place first. And then I put the values for A, B, C in the parentheses. Value of B, -3. Value of A, 5. Value of C, 0. You know, this part gonna be 0. Because if you have a factor 0 in the product, then the product is gonna be 0. Then we have -3 to the power of 2, which is 9. Turns out the discriminant is positive. So by the quadratic formula, x equals -b plus minus, remember the sum, plus minus square root of discriminant. Now you can put it here, right? Yeah. Sooner or later, you have to get the value for the discriminant, because the discriminant is the radicand of the square root in the formula. So I recommend you find the value for the discriminant first, and then apply the formula. On the bottom, we have 2 times A. Let's see. A is 5, twice of A, twice of 5, 10. B is -3. Opposite of B is 3. For some reason, people tend to mess up this part, the opposite part. Just slow down. It's not something complicated. B is -3. The opposite of B is +3, plus or minus square root of 9. What is the square root of 9, everybody? 3, right? So x equals, if we take the positive, 3 plus 3 over 10, that gives us 6 over 10, and that is 3 over 5. If we take the negative, 3 minus 3 over 10, that is 0. Do you see the 2 solutions? Thus, the solution set is a set containing 2 numbers There are 0 and 3/5. Yes, I know if you apply other methods, like a factoring method, you would have the same thing, right? Yeah, that's true. But as I said, we are practicing. We're practicing quadratic formula. All right, number 2. So this section actually pretty straightforward. You only need to understand, and remember the content of the theorem, knowing discriminant. If you apply quadratic formula to solve a quadratic equation, always evaluate discriminant first. Then you would know what kind of solutions you are expecting. If the discriminant is positive, you are looking forward, you're going to have 2 different real solutions. If the discriminant equals 0, then the 2 solutions of the equation are identical. You have one real number as the solution. If the discriminant is negative, you are expecting to have 2 conjugate, non-real, complex solutions, right? So let's see this problem. X squared minus 20x plus 100 equals 0. Yeah, it's in the standard form already, right? Then you tell me what is A, what is B, what is C. We have practiced this many times. In chapter 6, when we talk about the factorization of quadratic trinomial, we have this covered. A, B, C, right? Leading coefficient A is 1, B is negative 20, C is 100. And then what do? Why do we need to identify A, B, C? Because we want to know what is the value of discriminant, right? Yeah. Value of B, negative 20. Value of A is 1. Value of C, 100. What's the square of 20? Positive 400. What is 4 times 100? 400. Here we go. We got a discriminant equals 0 in this case. So what does that mean? Do you remember the content of the theorem we see earlier? Means the equation, this quadratic equation, gonna have 2 identical real solutions. Well, 1 real solution actually, but you're gonna know that is 2 identical solutions. The one solution actually have multiplicity 2, but that's not quite important at this point. In the future, if you have the chance to take a pre-calculus, that would be important at that time. All right. So by the formula we have x equals negative b plus 1 minus square root b squared minus 4ac all over 2a. In this case, the discriminant is 0, so we actually do not have that part anymore, right? So the blue part is gone. It's just a 0. And the numerator actually only have 1 term, which is a negative b, opposite of b. Yeah, there's a reason people mess this up. Maybe because of the sign. B is a negative 20. The opposite of B is a positive 20. Yeah, just slow down. Take your time. B is a negative 20. The opposite of B is a positive 20. A is 1. Twice of A is 2. So the solution to the one solution, again, is 2 identical solutions, okay? Yeah, the one real solution is 10. You conclude solution set only contain 1 number, which is 10. Okay? Yeah, if you apply the factoring method, you would end up with the same thing. Number 3. The equation is 2x squared minus 3x plus 4 equals 0. 2x squared minus 3x plus 4 equals 0. Okay, so let's see how do we apply quadratic formula to solve this equation. Same thing. We need to identify A, B, C. What is A? B, C, right? And then we go ahead to find the value for the discriminant, B squared minus 4AC. Again, you see this is the way I evaluate the expression, the discriminant. I use the parentheses to hold the place for ABC, and then put the values for ABC inside the cell. The value of B is -3. Value of A is 2. Value of C is 4. Square of -3, 9. -4 times 2 times 4, negative, positive, positive, that is negative, right? -4 times 4, 16. 16 times 2, 32. You have a calculator, so I don't worry about that. Just get familiar with your calculator. And what do you have? 9 minus 32. What do you have? Positive or negative? Negative. Yeah, in this case, the discriminant is negative. Negative 23. So we have one for each, actually. All right. So what kind of solutions you are expecting? We're going to have two non-real complex solutions. And those two non-real complex solutions are conjugate. I'm going to show you. Yeah. Remember the formula? Quadratic formula. Negative b plus or minus square root of discriminant. Yeah. In this case, is negative 23 all over 2a. What is a? 2. Twice of a, 4. What is b? Negative 3. What is the opposite of b? Positive 3. Plus or minus. Yeah, how do we rewrite square root of 23? Let me write it here again. How do we rewrite this part? Yes, you know that. We have those covered last week, right? Yeah. It is a positive square root 23i. Okay? So, the two solutions are x equals 3 plus root 23i over 4, or x equals 3 minus square root 23i over 4. Yeah, I'm going to take time to talk about the structure of the result, because you're going to always have this result in this structure. Left ear, yeah, you're going to see the Mickey Mouse again. Left ear, right ear, head. Okay? Yeah, sometimes you might tend to cancel out some factors, but be very, very careful. Left ear, right ear, head. Yeah, only as all the three parts have the same factor, you are able to cancel that common factor. Otherwise, please don't do that. Otherwise, you cannot. And you can also write a solution in this way: 3 over 4 plus root 23 over 4i. This one is 3 over 4 minus root 23 over 4i. You see the two solutions? They are imaginary numbers. Yeah, it means the imaginary parts are non-zero, or it's just the non-real complex numbers. They have the same real part, opposite imaginary part. All right? Yeah. Those are the two non-real imaginary solutions. All right, so the last part of my notes, not the last part, actually. I have example 3. Let's see another example here. On my note is example 3, but here actually this is the example 1, and I'm going to show example 2. Okay, determine the value or values for C such that C is the constant term in a quadratic equation, right? Such that x squared plus, what is that, 6x plus C equals 0, we'll have two different real solutions. Okay. Let's see how do we handle this problem. It's different. Previous example, the problems are very straightforward. You are given the equation, you are solved for the two solutions. Now, you are given that the equation has two different real solutions. You need to find a value for C. Determine the value for C. Yeah, let's consider how do we do that. In this equation, we have A equals 1, B equals 6. Different. Okay, this is B. That is 6. And C equals C is unknown. In order for the equation has two different real solutions, the discriminant needs to be positive. Do you agree? In order for the equation has two different real solutions, the discriminant needs to be positive. Okay. B squared minus 4AC. Yeah, I always do this because it could guarantee you don't make any mistake. B is 6, A is 1, C is C. We don't know what is C, okay? Yeah, the square of 6 is 36. 36 minus 4C, bigger than 0. We are solving this linear inequality. Remember, how do we solve a linear inequality? I'm going to get rid of the 36 here. Move 36 over, negative 36, or you can subtract 36 from both sides. And then I want to get rid of the negative 4. I want to divide both sides by negative 4. You know that, right? But don't forget, when we divide or multiply both sides of an inequality by a negative number, in this case is negative 4, we need to flip the direction of the inequality symbol. Okay, so we end up with C less than 9. Yes, we don't really have a value for C. We only know C gonna be less than 9. Then the equation would have two different real solutions. Is that clear? Example 3, the last one. Determine the value or values. Determine the value or values. Now you understand why we have a plural here. As you see in the previous example, any values of C, as long as it's less than 9, would be okay. So 8 is okay, 7 is okay, and many, infinitely many, uncountably many values for C, right? Or 8.999, yeah, so that is a plural. Yeah, determine the value or values for C, for A, this time is for A, such that A squared plus 4x plus 2 equals 0 has two non-real complex solutions. If it's non-real, it must be complex. Okay. So those two examples actually is to help you get more familiar with the content of the theorem. Yeah, the theorem is pretty straightforward. Let's see how do we find the value or values for A in order for the equation has two non-real solutions. Yeah. So A, B, C. A is A, right? We don't know. B is 4. C is 2. Okay. In order for the equation has two non-real complex solutions, the discriminant needs to be what? Positive, 0, or negative? You know that. Negative, right? Less than 0. So let's plug in whatever the values for A, B, C. B is 4. A is just A. C is 2 this time. 4 squared 16 minus 8A less than 0. We move. Yeah, you can always apply my transposition of terms. Yeah, move it over, you have a negative 16. And then I want to isolate the A on one side, on the left-hand side. So I want to divide both sides by negative 8, right? But remember, same thing. When you multiply or divide the two sides of negative number, you need to flip the inequality symbol. So they cancel out, we end up with A bigger than 2. As long as A is bigger than 2, then we would has two non-real complex solutions. The last part of this section I want to mention is on the notes. Yeah, this part. So the following procedure or the process, the following kind of like is how do we get a quadratic formula? Yeah, how come the quadratic formula look like that? So actually is we apply the completing square method to solve this equation. Yeah, I would let you to take the time to understand this part, and you end up with x equals negative b plus minus square root of b squared minus 4ac all over 2a. Okay, if you are interested, that's how do we have the formula, quadratic formula. All right, so this is section 10.2. Thank you for watching.